Dr. M.C. Sundaraja. He completed his undergraduate studies from Madurai Kamaraj University and went on to complete his Masters in Structural Engineering from the same. He is a doctorate from Anna University and he has also done his postdoctoral fellowship at the Queensland University of Technology, Australia. He has more than 17 years of experience in the teaching profession and he has also published papers in 39 international journals, 7 national journals, 27 international conferences and 51 national conferences. He has so far published 124 papers in various journals. He went on to receive the Best Research Paper Award from IFERP, a unit of VVERT and NIRE on 4th April 2015. He has also received Outstanding Faculty Award from the Venus International Foundation Faculty Award, VIFFA, in the year 2015. Currently, Dr. M.C. Sundaraja is now working as an assistant professor in Tyagarajar College of Engineering, Madurai.
Welcome to UGC lecture series in B Architecture. Let us have a discussion on Design of Structures 2, Unit 1, Lecture 7. In this one, we are going to design the doubly reinforced rectangular section. In the previous lecture, we have seen how to find out the moment of resistance, how to analyze the doubly reinforced rectangular section and how to find out the moment of resistance of the section. Using the expressions of the moment of resistance of the doubly reinforced sections, we are going to find out what is the reinforcement required for the doubly reinforced section. If it is this doubly reinforced section, which is normally consists of the reinforcement at the bottom as well as at the top. So, it is at the bottom it consists of AST1 plus AST2, total AST is equal to AST1 plus AST2, and at the top it is taken as ASC. Here also we are going to know how to find out the reinforcement. In the case of doubly reinforced section, first we need to design that section as a balanced singly reinforced section. That is, design of doubly reinforced rectangular section. So, here our aim is to find out AST1, AST2 and ASC. So, here we are having Bx into sigma CBC by 2 into d minus x by 3 plus 1.5 m minus 1 into ASC into sigma CBC dash into x minus d dash. This is a one formula which is used to find out the moment of resistance. Another formula is AST1 into sigma ST into d minus x by 3 plus AST2 into sigma ST into d minus d dash. Now, first to find out AST1. AST1, when you find out the AST1, assume our section is balanced, singly reinforced section. When you want to find out the balanced singly reinforced section, we need to first find out XC. XC by d minus XC is equal to sigma CBC by sigma ST by m. Once you find out XC, we can find out what is AST1. AST1 is, that is, first once you find out moment of resistance. So, moment of resistance balanced singly reinforced section is MR is equal to BXC sigma CBC by 2 into d minus XC by 3. This is the moment of resistance of the balanced singly. So, here this is the moment of resistance of the singly reinforced section, this is the moment of resistance due to compression reinforcement. Once you find out the moment of resistance of the balanced singly reinforced section, we can easily find out what is the area of AST1 required for MR. that is MR is equal to AST1 into sigma ST into D minus XC by 3. From that, AST1 is equal to MR by sigma ST into D minus XC by 3. This is the expression to find out AST1 required for a balanced singly reinforced rectangular section. And another one is R, it can be found from by equating these two things. These two, that is, this is the C1 to T1, that is compressive force C1 and the T1 are by equating C1 to T1 at the neutral axis, that is BXC sigma CBC by 2 is equal to AST1 into sigma ST. Using this expression, we can easily find out AST1. Then to find out AST2 and ASC. How to find out AST2? So, here AST2, it is the total moment of resistance is this one. So, we have found the moment of resistance of the balanced singly reinforced section, and total moment M is given in the problem. Total moment is given in problem. So, total moment M is equal to the moment of resistance of the balanced singly reinforced section plus M1 is the moment of resistance of the moment of resistance due to the compression reinforcement and due to AST2. So, to find first to find M1, that is excess moment, M1 is equal to M minus MR. So, for M1 find AST2 and ASC. For this excess moment, we are going to find out AST2 and ASC. So, M1 is normally equal to AST2 into sigma ST into D minus D dash. So, from this is MR. If we take this as M, this is M1. So, M1 is equal to, that is AST2 is equal to M1 divided by sigma ST into D minus D dash. Now, to find ASC. Now, by equating this C2 and T2, C2 and T2, that is by equating C2 and T2, that is 1.5 M minus 1 into ASC into sigma CBC dash, which is equal to AST2 into sigma ST. So, from that we can easily find out what is ASC. AST2 sigma ST divided by 1.5 M minus 1 into sigma CBC dash. This is a one expression. This is the expressions which is used to find out ASC. R, we can also find out using this R, M1 is equal to 1.5 M minus 1 into ASC into sigma CBC dash into D minus D dash, that is this expression. So, from this ASC is equal to M1 divided by 1.5 M minus 1 into sigma CBC dash into D minus D dash. This is the formula to find out the area of steel required for the doubly reinforced section. Now, here to design the section, that is to find XC, first we are finding the XC, then by equating C to T we are finding AST1, then we are finding moment of resistance of the balanced section, and we are finding the excess moment M minus MR. For the excess moment we are finding AST2, and also we are finding ASC by equating the area of, that is equivalent area of tensile steel to the compressive steel about the neutral axis. Now, we need to design the section. Here they have given the section, first formula, that is first problem, a doubly reinforced section is given. this is a reinforcement at the tension zone. So, this is AST, which is equal to AST1 plus AST2, and this is ASC, which must be placed at D dash from the topmost extreme fiber. Now, here the section is 360 by 750 mm, that is B is equal to 360 mm, D is equal to 750 mm, that is D is equal to 750 mm, is correct. This one is 360 mm. Now, beam has to resist the bending moment of 300 kilonewton meter. M is equal to 300 kilonewton meter, and find the tensile and compressive steel required. Sigma CBC 7, sigma ST 190, D dash 50. Sigma CBC 7 Newton per millimeter square, sigma ST is 190 Newton per millimeter square, and D dash is equal to 50 mm. Find AST and ASC. Ask us to find out here 7 190 and D dash is 50 mm. Okay, that is equal to 50. Now, first to find out XC, that is XC by D minus XC is equal to sigma CBC by sigma ST by M. So, XC by D is 750 minus XC is equal to sigma CBC is 7, sigma ST is 190 divided by 7, for 7 it is 13.33, XC must be equal to 247 mm. So, first by assuming it is balanced singly reinforced section. So, balanced singly reinforced, we have found XC. Now, to find out AST1 for balanced singly reinforced section. Before that, we need to find out MR of balanced singly reinforced section, that is MR is equal to BXC sigma CBC by 2 into D minus XC by 3. Using this expression, first we need to find out the moment of resistance of the balanced singly reinforced section, that is here it is 360 into 247 into 7 by 2 into D is 750 minus 247 divided by 3. So, the moment of resistance of the balanced singly reinforced section is 207.8 kilonewton meter. Now, to find AST1 for balanced singly reinforced section, at the neutral axis C1 is equal to T1, that is BXC sigma CBC by 2, which is equal to AST1 into sigma ST, or MR is equal to AST1 sigma ST into D minus XC by 3. This is the moment of resistance balanced singly reinforced section. We can also use this expression to find out AST1. So, AST1 is equal to MR divided by sigma ST into D minus X by 3, XC by 3. So, here by substituting MR is 207.8 into 10 to the power 6 divided by sigma ST is 190, D is 750 minus 247 by 3, 750, which is equal to AST1 is equal to 1638 millimeter square. Now, to find out AST2 and ASC for excess moment. The excess moment, that is the remaining bending moment, M1 is equal to M minus Mr. M is given in the problem, that is M is 300. 300 minus Mr. Mr we have found 207.8. For this excess moment, we are going to design AST2 and A, since it is doubly reinforced section, that is this is 90.2 kilonewton meter. Now to find out AST2, that is M1 is equal to AST2 into sigma ST into D minus D dash. Suppose AST2 is equal to M1 divided by sigma ST into D minus D dash, which is equal to 29.46 into 10 to the power 6 divided by sigma ST is 190, D is 750 minus D dash is 50, which is equal to, that is AST2 is 421 millimeter square. But total AST1 plus AST2, that is AST1 is 1638 plus 421, which is equal to 140, this is 90.2 kilonewton meter. M1 here it is 90.2 kilonewton meter. Sigma ST 190, that is equal to, this one is 693.23 millimeter square. Then total AST is 21408 623.28 2331.23 millimeter square. Here this one is 693.23 millimeter square. So total AST. Now to find ASC. ASC can be found by M1 is equal to 1.5 M minus 1 into ASC into sigma CBC dash into D minus D dash. So ASC can be found from this expression 1.5 M minus 1 into sigma CBC dash into D minus D dash, or 1.5 M minus 1 into ASC into sigma CBC dash is equal to AST2 into sigma ST. ASC is equal to AST2 sigma ST divided by 1.5 M minus 1 into sigma CBC dash, that is equal to 1242.14 millimeter square. So that's all about the design of the doubly reinforced rectangular section. So here we have used one worked example to find out design of the doubly reinforced rectangular section. So here they have given the size of beam, and the beam has to resist the bending moment of 300 kilonewton meter, and they ask us to design the reinforcement, that is both tensile and compressive steel reinforcement. So here the stresses in concrete and steels are given in the problem. So we have started designing the section, that is first we have found the area of reinforcement required for a balanced singly reinforced section at a neutral axis E1 is equal to T1. So or the moment of resistance equal to AST1 sigma ST D minus XB3. So we have found the AST1 required for it, and we have found the excess moment, that is excess moment is the given moment minus the moment of resistance of the balanced singly reinforced section, that is 90.2. For the 90.2 kilonewton meter we have found AST2 and we have found the total AST, and for finding out ASC we have equated the moment of area of compression side to the moment of area on tension side, or we can use this expression to find out the ASC required for it, that is 1242.14. So here if you want to find out this is AST1, this is total AST, we can assume the diameter of the reinforcement and find out for example, assume diameter of that is 25 mm diameter. We can find out number of bars required for it. Number of bars is 2331.23 divided by area of 125 mm diameter bar. We need to find out. So, we can easily provide how many number of reinforcement required for it. At the same time, here also assume the diameter of reinforcement. I can also have 16 mm diameter bar. So, number of bars is equal to 1242.14 divided by pi by 4 into 16 square. So, we can easily find out how many numbers we need to provide. So, this is the rectangular section. We can easily provide the reinforcement required for it. If it is AST, this is AST and this is ASC, and this is the size of section D by B. Now, let us summarize the lecture. In this lecture, we have discussed about the working stress design method of a doubly reinforced rectangular section. So, we have worked out one example. In this example, they have given the size of section as well as the stresses in the concrete and steel. They have asked us to design the area of reinforcement required for it. Since it is a doubly reinforced section, so we need to find out area of steel required at the tension zone as well as at the compression zone. In the case of tension zones, it consists of AST1 and AST2. AST1 is which is used to find out which is the area of reinforcement required for the balanced singly reinforced section, and AST2 is which is used to balance the reinforcement which is provided at the compression zone. So, and for finding out AST2, we are finding the excess moment, that is excess moment which is found from the total moment minus the moment of resistance of the balanced singly reinforced section. For that excess moment, we are providing the additional tensile reinforcement at the bottom, that is taken as AST2, and for balancing that one we have provided the reinforcement at the top, that is for M1 also we are going to provide, we have provided the reinforcement at the compression zone, that is ASC. So, this AST2 is used to balance this ASC, that is called as additional tensile reinforcement, that is AST2. So, the total AST is normally called as AST is equal to AST1 plus AST2. So, this is the way we have designed the doubly reinforced rectangular section by using one worked example. And in the question here also they have asked us to design the section by giving as a size of section as well as the external moment carrying capacity of the beam. So, here a doubly reinforced concrete beam 250 mm wide and 600 mm deep overall has to resist an external bending moment of 95 kilonewton meter, and to find the amount of tensile steel and compressive steel required if covered to the center of steel on both sides is 50 mm. Here they are given sigma CBC as a 5 Newton per millimeter square and sigma ST as 140 Newton per millimeter square. So, here also first we need to assume our section is the balanced singly reinforced section. We need to first find out what is the AST required for the balanced singly reinforced section, by that is at the neutral axis CE equal C1 is equal to T1, and find out the area of reinforcement, that is AST1 required for the balanced singly reinforced section, and we need to find out what is the moment of resistance of the balanced singly reinforced section. Then normally we know that the moment of resistance of the doubly reinforced section is the moment of resistance of the balanced singly reinforced section plus moment of resistance due to the compression reinforcement. So, here we need to first find out what is the moment of resistance of the balanced singly reinforced section. So, given moment, the moment is total moment of the problem is given in the problem, that is the moment of doubly reinforced section, which must be equal to the moment of resistance of the balanced singly reinforced section plus the moment due to the moment which is provided for the additional tensile reinforcement and the compression reinforcement. So, we need to first again we need to find out the excess moment, that is excess moment M1 equal to the total moment that is given in the problem minus the moment of resistance of the balanced singly reinforced section. So, for that excess moment M1 we need to find out what is AST2, AST2 which is equal to M1 divided by sigma ST into D minus D dash. Then for finding out ASC by equating the moment of area on compression side which is equal to the moment of area on tension side, that is 1.5 M minus 1 into ASC into sigma CBC dash is equal to M in AST2 into sigma ST. So, ASC we can easily find out from this expression. So, totally we can find out AST1, AST2 and ASC. So, here total AST is equal to AST1 plus AST2 and ASC we have found. So, this is the question, and with regard to the references, we need to refer IS 456 2000, that is plain and reinforced concrete code of practice, and we can also refer a book in order to work out some more examples, that is S. N. Sinha by Reinforced Cement Concrete Design. Let us come to the end of this lecture. Thank you.